So good morning, everyone, and welcome back to Data Structures Theory Sessions. We are continuing our unit number 2, which is linear data structures and their representations. In the second unit, we are discussing the first data structure, array. We have gone through 1D array, how we can declare it, how we can assign values, how to pass 1D array to the function. When we pass array, it is always going to be called by reference, right? Later, we looked at few operations on 1D array, like traversing, searching, insertion, deletion operation, merging two arrays. Maybe it is sorted or unsorted. After that, we've moved towards 2D array or multidimensional array. Few operations on 2D arrays are nothing but operations on matrices, like add to matrix, subtract, or multiply, transpose, and so. And just before we end the previous session, we were discussing this address calculation. Look, 1D array address calculation is very much simple one. How many number of elements are passed, multiply it with the size of element, and whatever answer you have, just add that number to the base address. Now the same logic we are going to apply here in 2D array, but calculating how many elements have been passed already is a trickier part, and that's where we discussed multiple things yesterday or in the previous session. So this is what the equation we found, right? And from now on, let's continue and go through the upcoming topics. The next thing that we want to discuss here is the sparse matrix. Matrix, which means it is 2D array. Now, can anyone tell me what is sparse? Well, I think, answer is on the screen right now. But at least you should know what is sparse and what is dense. You might have gone through these words already. Sparse and dense. Gujarati medium students may have some difficulties, but at least English medium students will know already what is sparse and what is dense. Well, if you consider a two-dimensional array, or let's consider a matrix, and within that 2D array, if you have less number of elements, you have less number of elements to store data. Remaining other elements are just null, nil, or zero, which is not required actually. Well, in that case, we can say it's a sparse matrix. So what is sparse matrix? A matrix which has many elements with value 0 or many elements where we do not want to store data. So, for example, if I say I have a matrix of 4 cross 4, which may have maximum 16 elements, but from those 16 elements, what if I only store 4 elements? Remaining 12 elements are 0. And the example for that, what is this? Which kind of matrix is this? Diagonal, principal diagonal has 1, all other elements are 0. Identity, well, there are multiple examples like lower triangular matrix, upper triangular matrix, diagonal matrix, eigenvector. In mathematics subject, you have seen multiple this kind of matrices. Now, where we say that very less number of elements are having data and all other elements are simply 0. Now, do I need to store those zeros here? If I know that I'm going to have elements in the principal diagonal only, then do I need to store remaining zeros? Is it necessary? If I already tell you that this is your data and it is a lower triangular matrix, अगर मैं ये बता देता हूं आपको कि भाई मेरे पास एक लोअर ट्रायंगुलर मैट्रिक्स है और ये डेटा है, तो उसमें अपर ट्रायंगुलर पार्ट आपको सेव करने की जरूरत है, यस और नो? जस्ट टेल मी यस और नो. This is the part where your lower triangular data will be. Do I need to store this upper part from the matrix? Yes? Otherwise? Yeah, if I go for 2D array, then definitely there will be some values, garbage values, and I need to assign 0 there. But what am I asking is, do I need to store that data? Do I need to have a memory for that? Look, when I say all these elements are 0, right? All these elements are 0, then I'm simply wasting that memory because I'm storing 0 there. It's not necessary for me actually. I'm occupying that memory, but in that memory space, I store 0. अगर मैं वो मेमोरी ऑक्यूपाई ही नहीं करता हूं तो वो मेमोरी बचेगा. You spare some memory and others may use. Now this is a very small amount of memory in this example, but this is not the actual or the real world example where you say you'll have only one array or only one matrix with size 4 cross 4 only. Maybe in real time you'll have 100 cross 100 array data, and maybe there will be multiple data regarding this where you are going to operate some process. But when you do that, if you occupy that memory, your software will be something like memory hungry. Your software will need more memory when you run it. And that's where software or the memory optimization comes. Now, in terms of process, how we do that will come later, maybe in upcoming semesters, optimization part. Right now, we are thinking about how, if there is a way by which I can convert this 2D array to 1D array. कुछ तरह से अगर मैं ये मैट्रिक्स को वेक्टर में कन्वर्ट कर पाऊं, मैट्रिक्स मीन्स 2D array, vector means 1D array. If somehow I can do that conversion, then I need not to go for or I need not to go for this amount of elements. मुझे वो चाहिए ही नहीं, जहां पे मेरा डेटा है मैं सिर्फ उसी को स्टोर करूंगा. And that actually will lower down the memory usage. And that's why we are going to have a look at this theory topic here, sparse matrix and its representation. So what are the sparse matrices? A matrix where you have very less number of data, or in other words, a matrix where more number of elements are 0. Now when we say dense, almost entire matrix is full with some data, then it can be called dense. Well, so it is beneficial to use specialized algorithms here so that the data structure that take advantage of the sparse structure of your matrix. and that's nothing but the utilization of your memory. Now, what are those algorithms? Specialized algorithms that we are talking about here is nothing but some kind of mapping. 2D to 1D. When we convert, we need to have some kind of mapping in between those two. So let's take an example of a lower triangular sparse matrix. Now this is the random example of one matrix. Okay, there is nothing like actual data, random numbers, but the structure of this matrix is lower triangular, which means the upper triangular part of your matrix is not required actually. Now all the elements above your principal diagonal will be 0, and we do not want to store it. So what we do is we are going to convert this 2D array to 1D array somehow. We are going to store this data in single dimension. Okay, and then we can take memory just enough to store this data. ज़्यादा memory लेंगे ही नहीं. So what are those mappings or those algorithms? So very simple one. When you have a 2D array, you consider each and every row one by one. You take your first row, you have data 1, so you have 1. Then you take your second row, you have 5 and 3, so next will be 5 and 3. Then you take your third row, 2, 7 and 1, you'll have 2, 7 and 1, and so on, right, up to 2, and the last one. So when you consider your entire row, it is called row-wise mapping. Now simply, if you consider your entire column, then it is called column-wise mapping. You take your entire column 1 to 9, and that is this data first. This is first column. Then you take your second column, and that will be this one. Then you take the third one, third column, right? After that you take the fourth column, 2 and 1, and then the last column. So it is called column wise mapping. So we are mapping, we are defining a structure to access 2D array. Whether am I going to access this 2D array row wise, or whether I'm going to access this matrix column wise. Once you define it, you have this mapping, row wise or column wise mapping. Then you have a simple continuous numbers, continuous data, and that will be simple vector 1D. Now when this is possible, point number 1, you should be knowing your original data, whether it is lower triangular or it is upper triangular or it is diagonal. What? Point number 1, you should be aware of your original data. And then point number 2, which mapping you are following. एक बार अगर decide कर लिया कि मैं row wise mapping में जाऊंगा, then it is fixed. You always need to go for row wise mapping, because आपका at the end memory के अंदर आपका यही data रहेगा. Either it is row wise or it is column wise. Now then comes a question. Okay, let's say lower triangular matrix is there, we know that, and we have also decided I'm going to go for row wise mapping. तो जब अगर मैंने ये decide कर लिया I am going for a row wise mapping, then the resulting array in my program or in a memory will be this one: 1, 5, 3, 2, 7, 1, then 3, 1, 4, 2, 9, 2, 8, 1, 7. So finally you have this data in your program. अब तो प्रोग्राम के अंदर कहीं पे भी वो 2D array दिखने वाला नहीं है. Finally we have this, but at the end actual data is 2D, जिसको हमने कन्वर्ट कर दिया 1D में. एंड यूजर तो यही बोलेगा कि थर्ड रो का सेकेंड एलिमेंट चाहिए. हाउ आर यू गोइंग टू फाइंड थर्ड रो सेकेंड कॉलम फ्रॉम दिस 1D array? How will you find it? Here we have only one index. User is asking for row and column. Now that's why we need those 2 points. Point number 1, original structure, right? And point number 2, mapping. That's why we need these 2 things. Now when I say my original structure is lower triangular, and the mapping is row wise, then you can define your data will be something like this one. Places. Okay, this is not one, this is just a place where your data will be. And from this structure, you can decide first row will only have 1 data. Second row will only have 2 data. Third row will only have 3 data, and so on. So now if user says, I want third row and second column, so 2 rows are passed iteratively. From first row 1 data, second row 2 data has already passed. पहली रो से 1 डेटा गया, दूसरी रो से 2 डेटा गया, and then from the third row I want second column, तो एक और column पास हो गया. Now these many elements are passed. Number of elements मिल गए हैं आपको, then very simple. This is your final required data. And this can be easily converted to program. Write iterative loop. Okay. If you want 3-2, then write iterative loop for number of rows. और हर बार आप क्या करोगे? 1 plus 2 plus 3, वो लूप जितनी बार चलेगी उतनी बार 1 plus 2 plus 3 plus 4 plus 5 plus 6 करते जाओगे. That will be the number of elements in previously passed rows. आगे की रो के elements मिल जाएंगे आपको. And then at the end current column जो है -1 ऐड कर दो तो आपको number of elements मिल गए. Now that's how we can easily calculate and we find required element from this 1D array. तो प्रोग्राम के अंदर मेरी मेमोरी जो है वो इतनी है जितनी मुझे चाहिए. यूजर को पता नहीं चलेगा कि मैं 1D यूज कर रहा हूं 2D यूज कर रहा हूं. यूजर विल ऑलवेज थिंक ओके आई एम स्टोरिंग दैट डेटा इन 2D. यूजर मुझे रो कॉलम देगा, मैं उसे एलिमेंट भी दे दूंगा, उसे नहीं पता कि मेरे पास सिंगल रो है. राइट. So we save some memory here, but 2 things is must: original structure and mapping. Only then you can decide required element. Right. Now, so this is one example, lower triangular matrix, and we have seen 2 types of mapping: row wise mapping and a column wise mapping. Now what if I have upper triangular matrix? Try to quickly write down row wise and column wise mapping for this one. Go for it and quickly write row wise mapping and a column wise mapping for given array. Yes. I'll declare 1D array only, and the size of that array will be the number of elements I have, means number of data I have. That will be the size. We are not going to define it, we are just going to print it. How do you print? Space. Empty space will show you this empty element. And just how do we print this 2D form? In previous semester you might have gone for number of patterns, 1 2 3 ABC star patterns. Yes, other student? No, just give me the row wise mapping and column wise mapping. That's it. And very simple. You go for row wise, consider first row entirely, then you go for the second row, then you go for the third row, and so on. That will be the resulting row wise mapping. So it will be something like 1 2 3 4 5. Now this is your first row. Then you go for the second row, so it will be 6 7 8 9. That's your second row. Then you go for the third row, which is 1 2 7, and so on. So that's the result, row wise mapping. If you want to go for column wise, then you consider the first column, so it will have only 1. Then you consider your second column, 2 and 6. Then you go for the third column, 3 7 and 1, and so on. That will be your column wise mapping. Now again, point number 1, original data, upper triangular. And point number 2, which mapping we are following. If it is upper triangular and we are following row wise mapping, then the first row will be full. So first row will contain total how many elements? All elements equals to the number of columns. So that many, those many elements are coming from first row. So here you can say, okay, this is your first row. From 1D, you can say this is your first row. Then this is your second row, and so on. So that kind of mapping you can imagine. So we have seen row wise and column wise mapping. What if we have tri-diagonal matrix? What if we have diagonal matrix or tri-diagonal matrix? Diagonal matrix means only principal diagonal. But when I say tri-diagonal, we have principal diagonal, then one diagonal up, one diagonal below. So 3 diagonals we have here. Oh, obviously we may go for row wise mapping, column wise mapping here also. Go for row 1 6, then each row will have 3 elements. फर्स्ट एंड लास्ट रो को छोड़ के बाकी की सारी रो जो है वो 3 एलिमेंट्स रखेगी, बिकॉज वी हैव ट्राई डायगोनल मैट्रिक्स. सो 3 2 7 4 3 8 5 4 9. First and last row will have only 2 elements. Now that's what the structure, point number 1, original data structure. Now here point number 2 is somewhat confusing. Whether you go for row wise or whether you go for column wise, number of elements in each row and column will be same. First and last row में 2 element है. Similarly, first and last column में भी 2 element है. And all remaining rows and columns are having same number of elements. Well, still you can follow this row wise mapping and column wise mapping if you want. But for diagonal matrices, we have a third mapping. diagonal wise mapping, right? A diagonal wise mapping, where you need not to think about a row or a column. You directly consider entire diagonal, where you start with the principal diagonal first. 1, 2, 3, 4, 5. That is your principal diagonal. Then you take the upper diagonal. Okay. First is the principal diagonal, then the upper diagonal, and then the lower diagonal. That's the sequence. And that is nothing but the diagonal wise mapping. Again, I'm saying, now this example is 5 cross 5 matrix, right? This example is 5 cross 5 matrix. अगर आप 2D एरे में जाते हो तो 5 cross 5 एरे लोगे, 25 एलिमेंट्स आपके लिए अलोकेट हो जाएंगे. लेकिन आप यूज कितने कर रहे हो? 13. Correct, 13. We are only using 13 elements from those 25. बाकी की मेमोरी वेस्ट हो गई. So what we do now, if we go for diagonal wise mapping, then 2D array declare करने के बजाय आप 1D array declare करोगे जिसकी size होगी 13. You will declare 1D array with size 13. You have 13 elements, you have 13 data, you store it, done. जितना डेटा है उतनी मेमोरी ली, 13 एलिमेंट ही मैंने डिक्लेयर किए, उसी को यूज किए. तो 25 एलिमेंट में डिक्लेयर नहीं करूंगा, तो मैंने मेमोरी बचा ली. नाउ विद इन दोज 13 एलिमेंट्स, दिस इज हाउ आई एम गोइंग टू स्टोर माई डेटा. आई विल कंसिडर प्रिंसिपल डायगोनल फर्स्ट, उसका डेटा रख लो. उसके बाद अपर डायगोनल को कंसिडर करके डेटा सेव कर लो, एंड देन एट लास्ट यू वुड कंसिडर द लोअर डायगोनल and store that data, right? So this is the diagonal wise mapping, and that's the sparse matrix examples and mappings. Now there might be a question maybe somewhere in your exam or viva, or maybe, what is sparse matrix? And a matrix where more number of elements are 0, we call it a sparse matrix. How do we represent a sparse matrix? Upper triangular, lower triangular, diagonal, eigenvector, काफी सारे examples हैं. If there is a short note in maybe 6 marks or something, sparse matrix, then you have to go for everything. Define sparse, give some example, and then go for mapping, row wise, column wise, and diagonal wise mapping. Everything you have to write. A question may be asked, what kind of algorithms we can use to overcome the wastage of memory in sparse matrix? Then again, same answer. Well, a specialized algorithms where you define mapping from 2D to 1D, we can use. What it is? Row-wise mapping, you consider all rows one by one, or a column-wise mapping where you consider all columns one by one, and so on. And this is the example in your written examination. If you want to write, this is how you should write it. First, give a lower triangular matrix, and below that you define both the mapping, row wise mapping and answer, column wise mapping and answer, diagonal wise mapping and answer. Done. Okay, so that's very simple and very easy. We can say this is the topic, sparse matrix and its mapping. Any question till now? Write a value where? So what? Always principal diagonal will, how many elements will be there in the principal diagonal? Number of rows, correct? then how many values will be there in upper or lower diagonal? Is it? Can you calculate how many elements have been passed? Yeah. Okay. Thank you, Rucha. No queries, then fine. Let's have a look at few basic applications of stack. That's the last topic from array topic. Well, you have been using array since last semester. You know many applications. But just to write down something here, we can say, okay, arrays are widely used to implement some mathematical vectors. One example, a vector means 1D array, we can say. We can have some values here. Now this can be, try to understand, this can be a mathematical polynomial equation. Right? Where we just need to remember coefficients. Otherwise, equation structure is fixed. We just need to remember coefficients. Now, when user wants to say, okay, what if x equals to 1? We have a, b, c, d. We already know the structure of equation. Put x equals to 1, calculate the answer and give it. So in your program, you only need to store a, b, c and d. Right? What if you have system of equations? More than one equation you have. Then instead of vector, you need matrix. Yes or no? If you do have two equations, then there will be two vectors. Instead of having two different vectors, we have a matrix with two rows. So that will be the example or the application of 2D array. So mathematical vectors, matrices, maybe rectangular, any kind of rectangular table. We already discussed, like the budget calculation or spending calculation monthly, month-wise, category-wise, we store some spending amount. Or maybe the marks for entire class having different subjects. So the entry within that table will be marks only, float. So we can have 2D array. Even many database, you have database management system, right? DBMS subject, DMS subject. Even many databases do use 1D array to store one record. To store one record. Those elements are records, right? So it's something like there is a 1D array which is having multiple elements, and those elements are nothing but different records. Record 1, record 2, and so on. Now definitely entire record cannot be stored in a single element of array. Why not? Array is having homogeneous data items, and entire record is not a single entity. It has multiple members. When I say a student record, student will consist of enrollment number, roll number, name, phone number, address, marks, SPI, CPI. We can have a structure for that. And then what we can do is we store the address of that structure in the array. Then array is nothing but all the elements in that array will be addresses. Array के अंदर जो भी आएगा वो क्या होगा? Address होगा. अलग अलग address. Address का data type तो fix हो गया ना? We can have array now. Right? So that's how multiple databases makes use of arrays. Multiple data structures like heaps. Well, heap is not a part of our syllabus right now, but maybe in upcoming semesters you will see what is heap. But to understand heap, you need to understand tree. And that's what we have as a part of syllabus. So we will see tree. Okay. Then hash tables are our second last or last unit, hashing technique. At that time we'll touch upon hash tables. Stacks and queues. In second unit or just after this array, we are going to start stack. And in unit number 1, you have seen what is stack, what is queue. It's nothing but LIFO and FIFO structure. Last in first out is stack. First in first out, queue. Now to implement those data structures, we may also use array. So that's where arrays are used. These are the applications of arrays. And plenty of other applications that you have seen till now. Store marks of a student for 5 subjects. Store result of entire class. Right? You store it in array. You can also have character arrays. 1D or 2D. एक स्टूडेंट का नाम स्टोर करना है, कैरेक्टर एरे ले लो. मल्टीपल स्टूडेंट्स के नाम सेव करने हैं, नेम सेव करने हैं, देन 2D एरे ले लो, कैरेक्टर. It can be done, right? So there are a number of applications of stack you can write and you can have. Now this completes our array part. Excuse me. So that completes the array portion of unit number 2. Yes? Yes, it is not exactly linked list. It's an array which stores the address. If record internally has a list, then we can say it is a linked list. That's simply pointer. That's simply a pointer. When we call a linked list, link तो आ गया, लेकिन क्या वो list है? नहीं है. List कब बनेगा? When you have more than one elements, or in terms of linked list we call it node. जब एक से ज्यादा node है तो वो linked list बनेगा. Right? So till that time it is simply a pointer. It's array of pointers. Correct? Okay. Any other question? So in array we started with representation of arrays 1D, 2D. We have seen sparse matrix and representation also. Earlier we have seen storage structure of arrays, always contiguous memory allocation. In that part we have also gone for address calculation. And the last point was applications of stack. After arrays, we want to see stack now. Okay. So let's jump to the stack now. From our second unit, we are done with array and now we are going to start stack. So we are done with this array part and we want to discuss stack now. Well, inside stack, we will start with the basics of stack. Why we call it stack, how it looks, how it behaves. What is actually the concept stack? अगर वो array से बनता है तो नया नाम क्यों दिया उसको? उसका behavior क्या है? You already know that because in unit number 1 you have at least discussed all these data structures a little bit. At least overview आपने लिया था हर एक data structure का unit 1 में. But now in unit 2 and unit 3 we are going to consider those data structures in depth, and we will discuss operations on those data structures. So the concept of stack, and then we will see the operations on stack. It is nothing but push, pop, peep, change, display, is empty, is full, and so. Push is nothing but insert. अगर आपको एक डेटा स्टैक के अंदर इंसर्ट करना है देन इट इज कॉल्ड पुश. अगर स्टैक में से कोई डेटा निकालना है देन इट इज कॉल्ड पॉप. ओके, इफ यू वांट टू डिस्प्ले योर एंटायर स्ट्रक्चर, डिस्प्ले. इफ यू वांट टू चेंज पर्टिकुलर एलिमेंट, चेंज. इफ यू वांट टू चेक वेदर योर स्टैक इज फुल और नॉट, इज फुल. एक फंक्शन बनाएंगे, एक ऑपरेशन. Similarly is empty. Now what is pip? You just want to check what is on the top of your stack. आपको सिर्फ ये चेक करना है, उसमें कुछ नया नहीं डालना है, कुछ रिमूव नहीं करना है. You just want to have a look at what is that value which is there on the top. That's the pip operation. Pip operation आपको सिर्फ ये बताएगा स्टैक के टॉप में ये वैल्यू है. ना तो वो उसको डिलीट करेगा, ना तो वो कोई नया एलिमेंट इंसर्ट करेगा. इट इज ओनली गोइंग टू से दिस इज योर टॉप मोस्ट वैल्यू. दैट इज pip. So these are few operations and we will see how those operations can be done. And then next points are actually applications of stack. Stack is being used to convert your infix expressions, mathematical expressions, to prefix or postfix. So that's the polish expression and their compilation. Even we will see the evaluation. Okay, and the last one is Tower of Hanoi. Now, anyone knows what is TOH, Tower of Hanoi? It is just a puzzle. You have source, spare, and destination, 3 poles, and inside your source pole you have number of disks with different sizes. You have 3 pole, source, spare, and destination, and you have let's say number of disks. We consider 3 disks right now with different sizes. The requirement or the puzzle here is transfer all the disks from source to destination. Now comes constraints, rules of this game. At a time you can transfer only one disk. एक बार में आप एक ही डिस्क ट्रांसफर कर पाओगे कहीं पे भी. And the second point, smaller disk can be put on larger disk only. बड़ी डिस्क के ऊपर छोटी डिस्क आप रख सकते हो, इससे उल्टा नहीं चलेगा. So there are 2 points. At a time you can transfer only one disk, and the second point is smaller disk can be put on larger disk. Vice versa is not allowed. Now this is the entire explanation. Go for it. Now that will be Tower of Hanoi, not right now. When we go to that topic, we will see how can we do this. But in some extra time, if you are interested, go for this puzzle. There will be multiple solutions available online also, but there is a universal generalized solution, and that's what we are going to find out in this topic, where just to make you aware, we are going to use recursion. and here all these poles are something like stack. क्योंकि मैंने इस पॉल को किस तरह से बनाया, a standing pole with hard base. आप नीचे से तो डिस्क नहीं निकाल पाओगे. अ रिंग जो है वो ऊपर से ही इंसर्ट होगा, ऊपर से ही निकलेगा. सो दैट पोल, सोर्स, पेयर एंड डेस्टिनेशन इज नथिंग बट अ स्टैक. तो हमारे पास यहाँ पे 3 अलग अलग स्टैक हो जाएंगे. So that is nothing but a stack. So application of stack. Now when we implement recursion, it's a function call. Recursion क्या है? Calling the same function, correct. A function called again and again, not only again and again, a function called within. अंदर से ही आप उसी function को call, a function calls itself. तब भी वो रिकर्जन होगा, वरना मैं एक फंक्शन को 10 बार कॉल कर सकता हूं. दैट्स नॉट रिकर्जन. सो अगेन एंड अगेन नहीं, itself. Then and then only it is recursion. Now when there is a recursion, operating system makes use of stack. किसी को पता है? Have you discussed this thing in previous semester? A function call requires स्टैक. ऑपरेटिंग सिस्टम जो है वो ये हैंडल करेगा सब कुछ. लुक, एवरी फंक्शन विल हैव इट्स ओन पीसीबी, प्रोसेस कंट्रोल ब्लॉक. Let's discuss this thing because we have 5 minutes. We don't want to start a new topic stack right now, but let us discuss this thing. Every function in your program, it's a procedure. So every procedure will have its own process control block. Now ये कौन बनाएगा? Operating system is going to maintain this thing. Now when you have OS subject, operating system subject in next semester, then you are going to have this topic in detail. But इतना समझ लो कि आपके पास अगर function A है, then there will be one PCB for A. If you have another function B, then there will be another PCB for function B. Now when and another thing, let's say when you always start with main, right? A main is nothing but a function. So there will be a PCB for main also. Now when your function starts, operating system is going to have its PCB. तो आपका एग्जीक्यूशन मेन से स्टार्ट होगा, तो सबसे पहले एक प्रोसेस कंट्रोल ब्लॉक बन जाएगा मेन के लिए. अब उसके अंदर क्या होगा? Now this PCB will contain all the local variables, constants, local constants. It will have execution pointer. Execution pointer आपके मेन फंक्शन के अंदर, मेन के अंदर आपने 15 लाइंस लिखी है. जब आपका एग्जीक्यूशन स्टार्ट होता है तो आप लाइन 1 एग्जीक्यूट करोगे, देन लाइन 2, लाइन 3, लाइन 4. एट प्रेजेंट आप कहाँ पे हो कैसे पता चलेगा? देयर मस्ट बी सम पॉइंटर. ये हो गया, ये हो गया, ये हो गया, ये हो गया, मैं आगे बढ़ रहा हूँ. So there is execution pointer which maintains the current execution line, or which is pointing to the current execution line. So there is execution pointer which will be updated every time your statement is executed. जैसे जैसे आपके statement execute होते जाएंगे, ये execution pointer update होता चला जाएगा. And all those things, right? Now there are few more things in PCB, but अभी के लिए इतना याद रखो. Now let us assume कि आपने main में से function A को call किया. You call function A. Now when you call function A, execution will jump from main to function A. एग्जीक्यूशन वहां से जंप होके फंक्शन ए में चला जाएगा, राइट? नाउ व्हेन योर फंक्शन ए स्टार्ट्स, एट दैट टाइम पीसीबी फॉर ए विल बी डिफाइंड. तब तक नहीं है. जब फंक्शन कॉल होगा तब उसकी पीसीबी बनेगी. तो सेम थिंग विल बी देयर, लोकल वेरिएबल्स फॉर फंक्शन ए, देन ऑल अदर थिंग्स. फंक्शन ए का एग्जीक्यूशन पॉइंटर बी रहेगा. भाई फंक्शन ए की कितनी लाइंस एग्जीक्यूट हो चुकी है अभी तक. सो इट विल हैव इट्स ओन एग्जीक्यूशन पॉइंटर एंड ऑल. नाउ व्हेन यू से यू आर डन विथ फंक्शन ए, तो आप वापस कहां पे आओगे? मेन में. जब फंक्शन ए खत्म हो जाएगा देन वेयर यू विल कम बैक? मेन. कैसे पता चला मेन में जाना है? किसी ने बताया आपको? It will go always to main. Always main. How do you remember who called me? फंक्शन ए को पता है कि उसको किसने कॉल किया. Does function A knows who called it? How? अगर पता है कैसे पता है? हाँ. क्या मैं कोई વેરિયેબલ લીધો ફંક્શન એની અંદર એ રિટર્ન એડ્રેસ સ્ટોર કરવા માટે? હા. મેઇનમાં શું કામ જાય? ફંક્શન એ માંથી ફંક્શન બી ને કોલ કર્યું હોત અને ફંક્શન બી કમ્પ્લીટ થાત તો હું મેઇનમાં જઈશ. Return type is void. Let us assume function return type is void. I don't want to return anything. પણ return તો થાય ને? કયો object? When you call a function, main से function A को जब आप कॉल करते हो, जब ऑपरेटिंग सिस्टम एक नया पीसीबी बनाता है तो वो पुराना पीसीबी स्टैक के अंदर याद रखेगा. सो व्हेन यू गो फॉर फ्रॉम मेन टू फंक्शन ए, ओके, ऑपरेटिंग सिस्टम इज गोइंग टू रिमेंबर पीसीबी ऑफ मेन इन स्टैक and then it will create PCB of A. Now मान लो कि आपने फंक्शन A से फंक्शन B कॉल किया तो अगेन नया फंक्शन आ गया. सो ऑपरेटिंग सिस्टम इज गोइंग टू पुश PCB of A to the stack and then it will create PCB of B. So when you are done with your function, वापस कहां पे जाना होगा? ऑपरेटिंग सिस्टम विल पॉप अ पीसीबी. तो उसको कौन सा पीसीबी मिलेगा? जो लास्ट में इंसर्ट हुआ, दैट इज व्हाट द स्टैक. सो उसको कौन सा पीसीबी मिलेगा? ए. नाउ पीसीबी ऑफ ए हैज एग्जीक्यूशन पॉइंटर. फंक्शन ए का एग्जीक्यूशन पॉइंटर पीसीबी ऑफ ए के अंदर था. फ्रॉम दैट एग्जीक्यूशन पॉइंटर आपके एग्जीक्यूटर को पता चलेगा मुझे वापस फंक्शन ए के अंदर कौन सी लाइन में जाना है. बी को कुछ पता नहीं है. पीसीबी नोज एवरीथिंग. सो व्हेन यू कम बैक फ्रॉम बी, देन ऑपरेटिंग सिस्टम विल से ओके, पॉप वन पीसीबी. कौन सा पीसीबी मिला? ए का. ठीक है, उसका एग्जीक्यूशन पॉइंटर क्या है? लाइन नंबर 5. नेक्स्ट स्टेटमेंट विल बी द फिफ्थ लाइन ऑफ योर फंक्शन ए. नाउ व्हेन यू कंप्लीट योर फंक्शन ए, तब ये पीसीबी ऑलरेडी निकल चुका होगा. सो जब नेक्स्ट पॉप करोगे तो आपको कौन सा मिलेगा? मेन. अब मेन का भी एग्जीक्यूशन पॉइंटर खुद का अलग था. So from that execution pointer, you will know what is the next line, right? So that's how function calls are being managed by operating system. And operating system is making use of stack here. Recursion is nothing but a function call. जितनी बार recursion करोगे उतने नए PCB बनेंगे. पुराने PCB स्टैक में जाएंगे. एंड दैट्स वाई जब आप वापस आते हो तो पुरानी वैल्यू भी आपको मिलती है रिकर्जन में. वेरिएबल a इक्वल्स टू 5, दूसरी बार रिकर्जन में वेरिएबल a इक्वल्स टू 6 कर दिया. वापस आओगे तो 5 क्यों मिलेगा? बिकॉज दैट लोकल वेरिएबल इज स्टोर्ड इनसाइड PCB. Well, so let's conclude this session here. We have passed more 5 minutes here. So thank you everyone. Thank you for being part of this session here. In the next lecture, we are going to start stack. And we will start with stack understanding and stack operations. Thank you. Online students can leave this meeting and they can join the next one.